Hello viewers, in today's session we are going to discuss a special form of limit. So in this session we are going to discuss one important problem related to limits of this form, that is 1 raised to infinity, which is an indeterminate form, right? So here we are going to evaluate limits of this form, that is limit extends to a f of x raised to g of x. When limit extends to a f of x, it tends to 1, and limit extends to a g of x tends to infinity, right? So here we'll discuss an important problem which is related to limits of this form. And here this form is an indeterminate form of this type, that is 1 raised to infinity. So let us consider this problem. Limit extends to 0 sine x over x raised to 1 over x square, right? So let us first compare this limit with this form. So here we can take this limit as L, and if we compare this expression with this one, then the value of a is 0, and f of x is given by sine x over x, and g of x is equal to 1 over x square, right? So let us now find out these two limits. So here we see that limit x tends to a, that is limit x tends to 0, f of x is sine x over x. And from trigonometry we know that this is a well-known limit. Limit x tends to 0, sine x over x is equal to 1, right? So here this condition is satisfied, that is limit x tends to 0, sine x over x is equal to 1, that is limit x tends to a, f of x tends to 1. And here we have limit, then we have x tends to 0, and g of x is 1 over x square. So we can easily see that this limit, it tends to infinity, because when x tends to 0, then 1 over x tends to infinity, and 1 over x square also tends to infinity. So this condition is also satisfied. So we can now here claim that this limit is of this form, that is limit x tends to 0, sine x over x raised to 1 over x square is of this indeterminate form, 1 raised to infinity, right? So to get the value of such limits, we use this result, that is the value of this limit can be written as L. Suppose this limit is equal to L, right? So L can be given as e raised to limit x tends to a, and here we have g of x multiplied with f of x minus 1. So whenever we have limits of this form, that is the indeterminate form, 1 raised to infinity, and these two conditions are satisfied, then the limit L, that is this limit, is equal to e raised to limit x tends to a, g of x times f of x minus 1. So here we are now going to make use of this result to get the value of this limit. So we have L is equal to e raised to limit x tends to 0, a is 0, and then we have g of x. G of x is 1 over x square, and f of x is sine x over x, and we have minus 1. So now we have to evaluate this limit. So here we can make use of the famous L'Hopital's rule. So here we have e raised to limit x tends to 0. We can simplify this expression. So we have sine x minus x over x, and it is multiplied with x square. So here we have x cube. So to get the value of this limit, limit x tends to 0 sine x minus x over x cube, let us suppose that the value of this limit is equal to L, so that capital L is equal to e raised to small l. So here L is given by limit x tends to 0 sine x minus x over x cube. So to get the value of this limit, we are now going to make use of L'Hopital's rule. So now if we take x is equal to a 0 in the numerator and denominator, then we have sine 0 minus 0 over 0 cube. So sine 0 is 0, so we have 0 minus 0 is 0, and here in the denominator we have a 0. So this form is of the form that is 0 over 0. So we can apply L'Hopital's rule here, and we can differentiate the numerator and denominator with respect to x. So we have now d by dx of sine x minus x, and here we have d by dx of x cube. So now we have limit x tends to 0. The derivative of sine x is cosine x, and the derivative of x is 1. Derivative of x cube is 3x square, right? So now applying L'Hopital's rule, we have arrived at this step. Now again, if we take x is equal to 0 in the numerator and denominator, then we have cos 0 minus 1 over 3 times 0 square. So cos 0 is 1. So we have 1 minus 1. Here we have 0, and this is 0 over 0. So again we have the form 0 over 0. So we can again apply L'Hopital's rule by differentiating the numerator and denominator separately with respect to x. So we have d by dx of cosine x minus 1, and here we have 3 times the derivative of x square. So we have limit x tends to 0, and here the derivative of cosine x is minus sine x, and derivative of 1 being a constant is 0, and here we have 3 times 2x, right? So the derivative of x square is 2x. So we have now here a 6. So we can write 1 over 6, and limit x tends to 0. Here we have negative, so we can write negative over here, and we have sine x over x, right? And this limit is equal to 1. So we have minus 1 over 6 times 1, that is equal to minus 1 over 6. So the value of this limit is equal to minus 1 over 6. So the value of this limit, which is capital L, is given by e raised to small l. So we have the value of L as minus 1 over 6. So here we have minus 1 over 6, right? So the value of this limit is equal to e raised to minus 1 over 6.